Hi, everyone, and welcome to this episode of OnTech 360, your full circle on technology. Today, we're thrilled to have Gene Halsey from Via Optronics with us. Gene has had an incredible career in the electronics arena for over 2 decades, most recently serving as Via's Managing Director for Americas. Via Optronics is at the forefront of advanced optical bonding technology, touch solutions, and camera technologies, pushing the boundaries of innovation. So stick around as we explore optical bonding and the DNA of this remarkable company. We will dive into the sophisticated technology and materials they work with and uncover so much more. You won't want to miss it.
For having me. I appreciate the opportunity to talk about optical bonding, what we do with the technology, and a little bit about who VIA is. So to get started, VIA is basically a technology company, right? As Susan said, we're a technology company focused in a lot of different ways, but at the end of the day, we're trying to create custom bonded display solutions that can be used in a wide range of applications. And one of the biggest challenges when you get into these display solutions is how do you make these screens visible in all kinds of different applications, different use cases, different places that people want to take these displays. And managing that is a serious challenge that VIA has gone a long way over its 20 years in business to address. So if I look at the industrial markets in particular, right, a display solution for the industrial market must do a number of things, right? It must be able to work in a wide temperature range. You can imagine displays can be deployed in the middle of North Dakota in the dead of winter, right? And it needs to go down to very low temperatures. It has to work in the most humid and hot conditions that are out there. So being able to manage the wide range of temperatures and what goes on there is important. Shocks and vibration are obviously a big deal. You start putting these in aircraft, you put them in vehicles, you put them in other uses where the thing is shaking around. You need to be able to manage that. Durability is key, right? And as I alluded to a little bit at the outset, right, excellent readability in sunlight is a major challenge. So you take a display like on the bottom right here. If I'm out on a boat and I'm trying to work a fish finder and trying to see what's going on, I've got bright sunlight on the ocean shining down at me. I need to be able to see that screen. So what do I do to mitigate it such that I can see this in a wide range of brightness conditions? It must be extremely energy efficient, right? We know everyone is really focused on energy these days, and energy efficiency is key. And then it has to provide excellent uniformity across the visible area. You need to be able to see it from all angles and be able to expect that what you see in the center of the screen is the same that you would see at the edge of the screen. So when I tear down these displays, right, I look at a number of different factors. I start on the top side with the cover lens, right? This is the part that's on the outside facing whoever the user is going to be. Work backwards to a touch sensor. Most of the displays that VIA manufactures come with a touch sensor integrated into the stack, a wide range of different touch technologies, but it has an integrated touch sensor. And then had the display hinge assembly, right? Or basically where you put the LCD. That's the number 3 piece. It can be an LCD, it can be an OLED. You can do a number of different touch tech or display technologies there, excuse me. But managing the output of that display, right? So what do I do with the backlight? How do I get more light through the display? How do I get more light going out toward the user? And then what can I do with the reflections inside? And that's the bottom side. We optically bond these whole things together to make them do the things that we want them to do. So why optical bonding? So if I look at those 3 pieces that we talked about on the slide previous, 1, 2, and 3, the cover lens, the touch sensor, and the display, right? Light, ambient light, when it hits that cover lens, surface 1, it reflects, right? A typical piece of glass will reflect 4 to 5% of the light that hits it. When that light goes through that piece of glass, it reflects off the backside of the piece of glass, and it gets that same 4 to 5% reflection. Each time you get a reflection, that's a loss of contrast. It's loss of brightness coming through. right? And if you air gap these, which is basically you tape a touch sensor and cover glass to an LCD and leave an air gap in there, you can get sometimes some cases where the reflectance can be as high as 15%, or you're losing 15% of the brightness that's coming through that display. If in turn you turn around and optically bond that, depending on what materials you use, you can get that sometimes down even under 1% reflection, right? Which is a significant amount of brightness coming through. With VIA, we've come up with some proprietary ways to do that with our VIA bond technology. And it also, when you optically bond, particularly when you optically bond the way that we do, you can increase the mechanical stability and get rid of moisture and particles that are in there. So when we talk about shock and vibration, when we talk about wide temperature ranges and the ability of materials to expand and contract at wide temperature ranges, when you're going into optical bonding, you need to pay particular attention to the materials that you're going to use there. On the left-hand side is how optical bonding is traditionally done. This is most of what is out there in the market today. You put a cover lens, you put an LCD, and then you put a liquid material between those two. Liquid's dispensed down onto the LCD, and you push the cover glass down with the intention to spread that material out. There's a lot of challenges with that technology, right? How much liquid do you put in there? Where does that liquid go? How do you cure that liquid, right? You void the warranty when you right? If I have changes in a little bit of pressure on that cover lens, I can create glow marks or hot spots on the display that when I talk about uniformity across the display surface, that becomes a problem if you get those glow marks or white spots. And then it's also very hard to cure underneath the black mask of the cover glass, or underneath the bezel of the LCD in those spots that are circled in red. So there's some really tricky parts of optical bonding with the traditional process that are mitigated by what VIA's come up with our MaxView 2 process. And what's happens here is we take a resin material, a silicon resin material, and we preform it into an adhesive. So think of a sponge. We preform that sponge on the backside of the cover lens. And then what we do is we gently bring that cover lens down to touch the LCD. And if you imagine that cover lens coming down and that black areas that says preformed adhesive hitting the top of the LCD, you don't have to worry about that material going underneath the bezel of the LCD. You don't have to worry about that material being in the black mask area. It's exactly where you want it. So you're not getting any of those adhesive flows. You're not using pressure to disperse the material, so you don't have to worry about the hot spots. You get a much tighter control of what that bond line thickness is, depending on what your needs are, right? We can vary that bond line thickness to be whatever a customer would need. The other real benefit with this, it's fully repairable. I can rework these, right? So if there is a problem, if there's something that I need to do, I can go ahead and rework this and still salvage what in many cases can be a very expensive display on the backside. So I talked a little bit about what the material is, right? Via Bond Plus, the material that we use is a resin-based material. It's a silicon resin. Compare that off to acrylates that are out there. You can see the difference between the two. Acrylates, tend to yellow over time. They don't have as wide a temperature range. They need something to activate them. They're not self-curing, right? So ours self-cures over a period of time, depending on, again, what the hardness of the final result you want to be. So when we look at the two, we have very much as VIA doubled down on what resin means and why resin is the right solution to use in these applications. And we developed then the MaxView 2 process around the resin-based material. It can create very thin bond lines. It can do things like shapes, right? So if I want to do these on curved lenses, if I want to do them on shaped lenses, I can do that because I've got this flexible sponge, again, attached to the cover lens and touch display that I can conform to whatever the shape of the display may be. So if I did this on a cover lens, like on the picture up here, right? I did one side without optical bonding, I did one side with optical bonding. This kind of talks about what the pieces that we're dealing with here, right? High reflection when I don't have optical bonding. Very hard to see what the display is behind that. So the contrast ratio, if you will, the effective contrast ratio of that display goes down significantly without optical bonding. I've made it much more mechanically stable. I can deal with those shock and vibration things that I talk about. I can put it into aircraft applications and not worry so much about what is going to happen at altitude, right? I can put it in these hard places that displays want to be. Everyone wants a display in those applications, but it's very difficult to put that, especially if I want to add touch, especially if I want to add cover lenses. So this is really the know-how that VIA brings to the industry and is really trying to evangelize what the benefit of doing this differently than sheet acrylics or liquid acrylics that are out there today. So if I summarize this is just one way to kind of look at this in total. Again, I very much appreciate the opportunity that JF Kilfoyle has given us. We enjoy working with their team and look forward to the opportunities to talk about this in more detail with anyone. But optical bonding, it's all about sunlight readability and getting rid of those internal reflections, making it more mechanically robust and protecting the inside from any kind of dust particles or any optical abnormalities that would get in there. We are very much a silicone-based company based on silicone optically clear resin, OCR. We think it's the best solution for what's out there for the widest range of applications. Our process, the MaxView 2 process, this notion of creating the sponge on the backside of the cover lens and touch panel, those Surface 1, 2 that we talked about before, we think is the best way to manufacture an optically bonded assembly. When you put these all together, we feel like it gives the widest range of customers the best experience when it comes to optically bonding. And again, would love the opportunity to talk to anybody about this in more detail. But Susan, again, thank you for the opportunity and look forward to talking again soon.